Hello everyone, and today we're going to go over the basic factoring things that you're going to see on our upcoming test. So here we go. So in this video, we're going to cover factoring greatest common factor, factoring PS2, doing the slide or grouping method, whichever method your teacher teaches, solving equations by factoring, the zero functions, and we're going to talk about vertical velocity problems. Now again, if for any reason you're not really sure of any of these things after we go through them, please go back and watch the videos that I have saved on my YouTube channel. Okay, so you can go back and review the playlist of factoring and solving by factoring. All right, so here we go. All right, so let's start with this first one. We're asked to factor out greatest common factor. So remember, greatest common factor, or GCF, is something that all the pieces share that I can divide out. Okay? So let's start with the regular numbers between 3, -12, and 18. What great multiple do these guys have that I can divide out? And the answer is 3. So when we take something out, remember, as greatest common factor, it's like we're dividing. So 3 divided by 3 is 1. -12 divided by 3 is -4. 18 divided by 3 is 6. Okay. Now for the x's, we have x to the 5th, x cubed, or x squared. Now remember, we want to take out as many x's as we can without going over creating negative exponent here. So kind of the rule that my students have come up with over the years is, if it's shared by all the pieces, look for the smallest exponent. It tells you how many you can take out. So in this case, we can take out 2 of them, or x squared. Now when we do our division, remember, it's like we're subtracting. So again, we have 5 x's here. I take 2 x's out. That leaves 3 x's here, so x cubed. In this part, I have 3 x's here. I take 2 x's out. That leaves 1 x here. And here I have 2 x's in, I take 2 x's out, so nothing is left on the 6. Now for the y, here's where you got to be careful. We have y to the 7th, we have y to the 8th, but I don't have anything here. Technically, remember, this is y to the 0. So you can think of it in 2 ways. Since this third piece did not have a y, you can't take out y's. Or if you want to think of it as, well, I'm taking out y to the 0, okay? If I had 7 y's in and I don't take any y's out, that still leaves y to the 7th here, y to the 8th here, and nothing here. So this would be your answer, taking out GCF. All right, let's move on. All right, factoring using PS2. So let's start with this one. So again, remember, PS2 method, we have to have 3 pieces with no number in front of x squared. Okay? So when we have this, we can use PS2. All right, so my product, remember the piece on the end, so positive 20. My sum in this case is going to be right here, so positive 12. So now the hardest part. The 2 numbers that multiply to 20, but add to give me 12. Now again, if you get stuck, list off the multiples of the product in order. So 1 and 20. Will that add to 12? No. 2 and 10. That'll add to 12. So we have 2 and 10. Now at this point, we need the signs to give me a positive 12 when I add them together. So in order to do that, they both have to be positive. Okay, so now don't forget the check with PS2. So it says, if I take 2 and multiply it with 10, do I get positive 20? Yes. If I take 2 and add 10, do I get positive 12? The answer is yes. If I say yes to both questions, we know we're good. If you say no, something's wrong, and you need to go back and fix it. All right, so we're going to have x and x. That makes up my x squared up here. We'll do the plus 2 and plus 10. Now remember, the order of the parentheses does not matter. So if you did x plus 10 and x plus 2, that is technically correct. All right, let's take a look at our next one. All right, so I've got 3 pieces. Nothing in front of the square. So that tells me I can use PS2. Alright, so we're going to start. My product right here is negative 28. My sum, positive 12 again. So I need two numbers that multiply to 28 but subtract to 12. Multiply to 28, subtract to 12. So I list 1 and 28. Does that subtract to 12? No. 2 and 14 does though, so we're going to go with that. So we're going to go 2 and 14. Now be careful. I need these to subtract to give me a positive 12. So since this is positive, it tells me the largest number has to be positive. This therefore has to be negative. Okay, so now at this point, let's check it. Negative 2 times 14 is negative 28. Negative 2 plus 14 is positive 12. Okay, so we're good. So we're going to have x minus 2, x plus 14. All right, this next one I didn't really talk about in my previous videos, so that's why I kind of saved this one for the review. Okay, so we're going to start the same way we always do. I've got 3 pieces, nothing in front of the square. Okay, so I can use PS2. Product is negative 3. The sum is going to be positive 9. But here's my problem. What two numbers multiply to 3 but subtract to 9? Nothing, right? We can't get our two numbers because they don't exist. So when the answer doesn't occur and I can't do anything, we would write the problem is prime. Okay, all right, so let's move on. All right, now this one we're going to talk about the 2 different ways. Now, depending on how your teacher does this, now I'm going to demonstrate both ways so you can see it. First way I'm going to do is the slide method. So again, notice how I have 3 pieces and I got a number in front of the square. So I cannot use PS2, so I'm going to use the slide. So we're going to multiply front to back and get plus 12. So now I'm going to put in my slide, so I'm going to split the 3 and the x squared. I'm going to cut away the 4 and make that go away. I don't need it. And then we're going to do our mini PS2. So my product, positive 12. My sum, positive 8. So the 2 numbers that do this are plus 6 and plus 2. Now, here's the trickiest part about the slide, folks. Don't forget, since we did the slide, we have to divide by the lead coefficient. So this 3, we now have to divide everything by the 3. Okay, so when I do that, I'm going to be reducing these fractions right here. So you're going to have x plus 2. Now, try to reduce 2/3. You can't, so that means we're going to take the 3 and scooch it in front of the x. So you're going to have 3x plus 2. And there's that one. Okay, so that's slide method. Now, the next one I'll do grouping method on so you can see it. So again, we're going to start. I have 3 pieces. I've got a leader in front, so I cannot do PS2. So we're going to use group. So I'm going to multiply front to back. I'm going to get negative 12. So now at this point, we're going to do our PS2. Our product is the negative 12 that I got from here. The sum, again, the number I see here is positive 1. So the 2 numbers that multiply to 12 but subtract to 1 are going to be positive 4 and negative 3. Now, here's where the slide differs. Now we're going to kind of set this up. We're going to do 2x squared dash x minus 6. Now I'm going to put these numbers on the line, so plus 4 minus 3. Now we're going to group these up. First and second, third and fourth. And we're going to do this. Line, parenthesis, line, parenthesis. Now what we're going to be doing is we're going to be taking GCF. So let's take the GCF out of the first parenthesis. So I can take out a 2 and an X, leaving me X plus 2. Now here's the catch. We need to make these parentheses match. So kind of a trick I teach my students is you're going to take the 6 here on the end, and we're going to divide it by what's here. And that tells me what goes on the line. So -6 divided by 2 is -3. And now we're going to divide the pieces in here by -3. So -3x divided by -3 is x. -6 divided by -3 is plus 2. And we got what we wanted. These things now match. So to do this up, x plus 2, that's our common piece. That's these guys right here. So that goes in our lead parenthesis. The second parenthesis, all the garbage on the outside left over. So we're going to have 2x minus 3. And there's your answer. Okay? So again, depending on which way you like the best, at least with my students, you have your choice. You can use either one. Okay? But again, if your teacher insists you have to use one way over another, make sure you're using the correct method. Okay? All right, so let's move on. All right, solving the equations by factoring. We've got 3 things. Oh, they cut off the 0 on the end over here. I'll have to put that in. Let's throw the 0. Cut that off. All right, now for this first one, super easy. Remember our steps. Step 1 says make sure one side of the equation is equal to 0, which it is. So since that's true, we don't have to factor. So we're going to pull the piece apart, set the pieces to 0, and solve the equation. So here minus the 2. So x equals -2. Add the 3. So x is equal to 3. And those are the easiest questions you're going to see on the test. And let me tell you, a lot of students leave these ones blank because they don't know how to do them. They're not that hard. All right, let's take a look at the second one. First things first. Again, remember, does one side of the equation equal to 0? The answer is yes. Step 2, factor. Now remember, anytime you're factoring, the first thing you always look for is GCF. So from these pieces, I can take out 2x, leaving me x minus 3 is equal to 0. Now at this point, now that we've factored it all the way, now we pull it apart. So 2x, x minus 3. Set the pieces to 0, set the pieces to 0. Solve. Now divide by 2. X equaling 0. Now again, common error is students tell me this is no solution. But remember, x is a variable. It can be anything it wants to be, including 0. So that's okay. Over here, add 3. So x is equal to 3. And there's your answers for that one. All right, for the last one, let's take a look at this. So first things first, does one side of this thing equal 0? Yes. Step 2, factor. Can I take GCF out? No, I cannot. So I've got 3 pieces with nothing in front of the square. That's PS2. So my product is positive 5. The sum is positive 6. 2 numbers that multiply to 5 and add to 6 would be positive 1 and positive 5. Oop. Okay, so now x plus 1, x plus 5 equals 0. And now that we factored, we pull the pieces apart. Set the pieces to 0. And now we solve. So minus the 1, x equals -1 minus the 5, x is equal to -5. Alrighty, so let's continue on. All right, zero function, or finding the zeros. You could hear it both ways. This, again, is where math people were tired of being abused, picked on, spit at, tripped at, bullied, swirlied in high school, and they come up with ways to get even with normal people by taking something very simple and turning it into something very complicated, like zero function, for instance. Again, zero function, or finding the zeros, basically says is you're going to take f of x and change it to 0. Like so. Okay? And now that we have it equal to 0, now we just do what we've been doing. So, does one side equal 0? Yes. Step 2 says to factor. Okay, so I've got 3 pieces with nothing in front of the square, so it's a PS2 again. Product is -20. Sum is -8. So our two numbers that multiply to 20 but subtract to 8 is going to be -10 and +2. Okay, so we're going to have 0 equaling x minus 10. X plus 2. And now we solve. Pull the pieces apart. Set the pieces to 0. And solve them. So add 10. X is going to be 10. Minus the 2. X equals -2. And there's that one. All right, let's take a look at this next one over here. So again, zero function. So first I'm going to change f of x to 0.
Put that in there, would you? I just want to.
Okay, now we start. Does one side of this thing equal 0? Yep. Factor. Take out GCF first. So we're going to take out a 3. I have x squared minus 2x minus 3. Now remember, we're going to put this in a big red balloon. It's going to float away for a while because they all float down here. And we're going to focus solely on this. I've got 3 pieces with nothing in front, so it's a PS2. Product is -3. Sum, -2. So two numbers that multiply to 3 but subtract to 2 are going to be 3 and 1. But signs to give me -2 when I add them or subtract them is -3, +1. 0 equals x minus 3, x plus 1. And now don't forget about this guy. Comes back and parks here. Hey, if it stays. All right, now let's pull these pieces apart. 3, x minus 3, x plus 1. X. Set the pieces to 0. Now solve the equations. Now be careful here. 3 equaling 0. And the mathematics you're aware of, does 3 ever equal 0? The answer is no. And we have to throw this away. This is no good. Here, at x minus 3 is 0. We add the 3. So x is 3. Here, minus the 1, because x plus 1 is 0. So x is -1.
I will fix your poop.
And there's that one. Okay?
She always tells me.
All right. So, let's move on to the next one. All right. Vertical velocity problems. Okay. So, we're going to start with this one. So, okay. So let's start. Now again, this is a word problem, so the first thing we always do is read the stupid thing first. Don't do anything but read it. A ball is thrown into the air from a platform that is 112 feet above the ground. The ball is thrown with initial vertical velocity of 24 feet per second. Create the equation that models the situation. Calculate how long it would take the ball to hit the ground. All right, so we start. We read this question again. A ball is thrown into the air from a platform that is 112 feet above the ground. So that's important. So we highlight it. The ball is thrown with an initial vertical velocity of 24 feet per second. Also important. Okay, here's where our problems come in. Create the equation that models the situation as part 1. Calculate how long it would take for the ball to hit the ground. So we have a two-part problem here. Okay, so we start with our equation. Now, because they're using, actually, let's set up our what we do know. So we had H. Oh, I keep doing that. We have H, we have T, we have V, and we have S. Because remember our formula pieces. Okay, height of the object. And H stands for ending height, remember. So where is this thing going to end up? Well, it's going to end up on the ground. So ending height of this object is 0. Time. That's what we're going to be looking for, so I don't know what that is. The V is the vertical velocity. And that's right here. Okay, so we're going to be 112 feet per second. Oh, correction. Sorry, I'm not right here. Back up, back up, back up, back up, back up. Eraser would have been easier. I was wrong on that one. That's not vertical velocity. The vertical velocity, you guys should be right here, right?
Green.
So vertical velocity, 24 feet
9.
per second. Okay. Now starting height, that's what's here. 112 feet
1.
above the ground. Okay. So let's start setting up our formula. Remember, because we're using feet, our formula H equals negative 16 t squared plus VT plus S. Again, H is ending height, T is going to be time, V is the velocity, and S is the starting point. All right, so let's fill in what we know. H. Okay, so for the first part, create the equation that models the situation. We don't replace the 0 with H right now. We would just say H equals negative 16t squared plus vertical velocity 24t and starting height is 112. That's part 1. Create the equation of the model. Okay. Now, second part then says calculate how long it would take for the ball to hit the ground. That's where we go here. 0 equals negative 16t squared plus 24t plus 112. Okay, now we start our process of solving by factoring. So step 1, does one side of this thing equal 0? Yes, it does. So now we start to factor. Okay, so remember, I have to take out a negative because my lead piece cannot be negative. Now let's take a look between, let's see, is 112 divisible by 8? So let's take a look at that. I do believe it is. So let's see, 112 divisible by 8, it is 14. I can't do more than that because of the 24. So I can take out negative 8 as a GCF, leaving me 2t squared minus 3t and minus 14. Now again, remember, the signs here changed because I took out the negative. Okay. So now we have to, again, we're going to put the GCF in a big red balloon right now. It's going to float away for a little while. Okay. Rose, watch the language. Okay. So now we're going to focus solely on here. So I'm going to use the slide, multiply front to back, I get negative 28. Okay, I'm going to split the t squared and the minus 14. Okay, so my product, negative 28. My sum, oops, that's not an S. My sum is negative 3. So two numbers that multiply to 28 but subtract to negative 3 is negative 7, positive 4. So going to have x minus 7,
Just put down the 3.
x plus 4,
Put down the 3.
0 equals, and now we're going to bring this negative 8 back.
Congratulations.
Now, don't forget, we did the slide, which means we have to divide by that lead. So divide by 2, divide by 2.
Uno.
Negative 8.
Oh, really?
Now, I can't reduce
You
this.
shouldn't have done that.
Now,
Every
I'm not
single
going
word,
to,
every single color.
I'm not going to put the slide in front because we're solving an x plus 2. Okay. Now let's pull these pieces apart.
6.
Negative 8,
That's another thing I need.
x minus 7, x plus 2. Set it equal to 0, set it equal to 0, set it equal to 0.
1.
Now solve.
3.
Negative 8 equaling 0 doesn't make sense, it's gone. Here I'm going to add the 7 halves, so x would equal 7 halves. But again, we need to put this in proper form. So that'd be 3 1/2. Or you'd write it as 3.5 seconds. And then here, if I solve, I minus the 2 over x equals negative 2. But again, remember, I can't have negative time because that says the ball hit the ground before we dropped it. So that's gone. So it took 3.5 seconds for this ball to hit the ground.